Chapter 2, Problem Solving. The goals of this lecture are to develop the problem-solving skills needed for physics and to have a general math review. In this course, we will be using a number of equations and formulae, so we need to know what a formula is and how to use formulae. A formula is a statement asserting the equality of two mathematical expressions. In physics, a formula relates two or more physical variables, such as height, weight, speed, and distance. The area of a circle is pi times r squared. It relates the area of the circle to the radius of the circle. But pi times r squared by itself is not an equation. It is an expression. Equations must have an equal sign. Consider the force equation, F equal ma, which says the force is equal to the mass of the object times the acceleration. Probably the most famous formula, E equal mc squared, tells us the amount of total energy stored in any mass. From time to time, you will be given a formula and asked to find a value. You need to find a numerical answer for this given data. We call this solving for the unknown. For example, using the force equation, F equal ma, let's suppose we are given some of the quantities and need to find the unknown quantity. In the example, we are given a mass of 10 kilograms and are asked what the force needed to cause the mass to accelerate to 2 meters per second squared. We write the formula F equal ma. We substitute in the known values, 10 kilograms and 2 meters per second squared. This is one difference you will see between math and physics courses. In math, these are just numbers. In physics, all values have units, kilograms, meters, meters per second squared, and so on. If an answer does not have the correct units, even if the number is right, the answer is wrong. We will explore this more later. Multiply the values and the units. Put the answer in its final form with an answer of 20 newtons. In this example, we have the same force equation and want to solve for the acceleration a. Divide both sides of the equation by m. This gives the acceleration is the force divided by the mass. Insert our values of F equal 20 newtons and m equal 10 kilograms and solve for the acceleration gives 2 meters per second squared. In this equation, we want to solve for the variable c. We are not looking for a numerical answer, just to rewrite the equation. In math, you would have to have learned that there are independent and dependent variables in an equation. In E equal mc squared, E is the dependent variable. It is dependent upon the values of m and c. We would like to rewrite the equation so c is the dependent variable, dependent on E and m. What should the first step be? Divide both sides by m. Then what is the next step? Take square roots of both sides, which yields for the final answer that c is equal to the square root of E divided by m. Our reason for using formulas is that we seek to represent the physical world in the most generalized way possible. We can say that the weight of an object is 10 pounds on Earth, but that is specific to one object at one location. We seek a more generalized statement, such as W equal mg. Here, weight, represented by W, is the mass of the object times the pull of gravity. The mass of an object doesn't change. The pull of gravity, on the other hand, is different for different planets. By knowing g for a planet, we can predict the weight on different planets. To solve problems, we will use an 8-step strategy. Step 1, read the problem carefully. Decide what you are looking for. Step 2, make a sketch. Physics is very visual, and you need to see the problem. Write all given information, including units. Step 4, write the unknown or quantity asked for in the problem. Step 5, write the basic equation or formula that relates the known and the unknown quantities, such as F equal ma. 6, find a working equation by solving the basic equation, including the appropriate units. If we are looking for A, we have to manipulate the equation. Step 7, perform the indicated operations and work out the solution. This is the do the math step. In step 8, check your answers. Does your answer make sense? In this example, a storage bin is in the shape of a cylinder containing 814 cubic meters of storage space. If its radius is 6.00 meters, find its height. Step 1. Read the problem carefully. The problem relates the volume of a cylinder to its height and radius. We need to know the formula for the volume of a cylinder. We make a sketch so we understand the relationship between height and radius. This is our known information. The volume is 814 cubic meters and the radius is 6.00 meters. We're looking for the height, h. That is our unknown, or our dependent variable. The basic equation is the volume of a cylinder. Equations like this are given in the book. There are several in the inside, front, and back cover of your book. The volume of a right circular cylinder is pi r squared times the height, where r is the radius of the cylinder, and h is the height. The working equation relates our unknown quantity, height in this case. We manipulate the basic equation to obtain the working equation. Here, the height is the volume divided by pi r squared. Substitute what we know into the equation. Since pi is a constant, it is assumed that you know that pi is approximately equal to 3.1415. Notice the units are kept in the equation. We find the numeric answer as 7.20. Since we are squaring the radius, the units in the denominator are also squared. We have meters cubed in the numerator and meters squared in the denominator. Units are used just like variables. They multiply, divide, and cancel. So meters cubed divided by meters squared leaves meters. Our final answer is 7.20 meters. Our final answer is to give a quick check. Here we use an estimation technique. The radius is 6 meters. The height approximately 7 meters, and pi is about 3. So 3 times 6 meters squared times 7 meters yields 756 meters cubed. This is close to the original volume of 614 meters cubed, so our answer is reasonable. The lateral area of a prism or pyramid is the combined area of its lateral faces. Similarly, the lateral area of a cylinder or cone is the area of its lateral surface. In other words, it is the sides but not the top and bottom. In the case of a cone, it does not include the bottom. Example, given a bedroom in the shape of a rectangular prism, the lateral area is the area of the 4 walls. Given a cylindrical soup can, the lateral area is the area of the can's label. The total surface area of a prism or pyramid is the combined area of its lateral faces and its bases. Similarly, the total surface area of a cylinder or cone is the combined area of its lateral surface and its bases. Total surface area includes the top and bottom. Examples, given a bedroom in the shape of a rectangular prism, the total surface area is the area of the 4 walls plus the area of the ceiling and the floor. Given a cylindrical soup can, the total surface area is the area of the can's label plus the combined area of the top and bottom of the can. The cylinder in an engine is 11.40 centimeters in diameter and 24.00 centimeters high. Find the volume of the cylinder, find the cross-sectional area of the cylinder, and find the lateral surface area of the cylinder. Note, since the values are given to 4 significant figures, the answer should have 4 significant figures. We are given the diameter of 11.40 centimeters. The radius is half the diameter, or 5.7 centimeters. The height is 24 centimeters. The unknown is the volume, so use the volume of cylinder formula. V equals pi times the radius squared times the height. Substituting the known values gives 2,450 centimeters cubed, rounded to 4 significant figures. The cross-sectional area is the area of the circular base. The radius is half the diameter, or 5.7 centimeters. We will not need the height. The area of a circle is pi times the radius squared. Substituting the known values give an area of 102.1 square centimeters to 4 significant figures. The lateral surface area of a cylinder is twice pi times the radius times the height. The lateral surface area is the area of the paper label on a soup can, unrolled, which is in the shape of a rectangle. The height of the paper is 24 centimeters. The length of the rectangle is the same as the circumference of the circular base, or 2 times pi times the radius. The radius is half the diameter, or 5.7 centimeters. The lateral surface area is then 2 times pi times 5.7 centimeters times 24 centimeters, or 859.5 square centimeters, to 4 significant figures. For Chapter 2 are to read Chapter 2 in the textbook and to do the Chapter 2 homework found on problems 2.1, 2.2, and 2.3, due on February 2nd.